At some point in your life, a piece of music did something to your body. Not metaphorically, physically. The hair on your arm stood up. A wave of sensation moved across your skin. Something tightened in your chest or rose in your throat. And for a moment, you were not just listening to sound. You were experiencing something that felt much larger than sound. Something that the music was pointing at, but that the music itself could not fully contain. Scientists have a name for this. They call it Frisson, from the French word for shiver, and it is one of the most mysterious responses in all of human biology, because no other animal on Earth experiences it in response to music. Your dog does not get goosebumps when a symphony reaches its climax. Chimpanzees exposed to music show behavioral responses. They move, they attend, they are affected in some way, but they do not show the physiological signature of Frisson. No primate does, no mammal does. The response, the specific combination of skin response, emotional intensity, and the particular quality of aesthetic experience that music can produce, appears in the research literature as a uniquely human phenomenon, and nobody fully understands why. Approximately 65 to 70% of people report experiencing Frisson, the music-induced chills. The remaining 30 to 35% never experience it or experience it very rarely. Researchers initially assumed this was a learned response, that people who had more musical training or more exposure to music were more likely to experience it. The data does not support this. Musical training correlates weakly or not at all with Frisson frequency. What does correlate, strongly and consistently across multiple studies, is a personality dimension called openness to experience, the trait associated with curiosity, aesthetic sensitivity, imagination, and the tendency to engage deeply with ideas and sensations. People high in openness to experience report Frisson more frequently and more intensely than people low in this trait. This is the first strange thing about Frisson. It is not primarily a musical phenomenon. It is a personality phenomenon that music happens to trigger most reliably. The neuroscience of what happens during Frisson has been illuminated by a series of studies that connect the music chills to some of the most fundamental reward circuits in the human brain. Valerie Salampour and her colleagues at McGill University published a study in 2011 that used PET scanning to measure dopamine release during music-induced chills. They found that dopamine, the neurotransmitter associated with reward, motivation, and pleasure, was released in two distinct brain regions at two distinct moments. In the nucleus accumbens, the brain's primary reward center, the same region activated by food, sex, and drugs, dopamine was released at the peak of the emotional response, during the chill itself. In the caudate nucleus, a region associated with anticipation of reward, dopamine was released in the seconds before the chill, during the buildup toward the emotional peak. The brain was rewarding itself twice, once for the anticipation and once for the arrival. This anticipation reward cycle is the key to understanding why music produces Frisson at all. Music works by establishing patterns and then violating or fulfilling them in unexpected ways. A melody creates an expectation. A chord progression builds toward resolution. A rhythm establishes a pulse that the brain starts predicting ahead of the sound, and when the music does something with those expectations, either resolving them perfectly or subverting them in a way that is simultaneously surprising and inevitable, the brain's prediction system registers a specific kind of reward, the pleasure of a correct prediction fulfilled, or the pleasure of a surprising violation that the brain immediately recognizes as better than what it had predicted. This is why the same musical moment can produce Frisson the 100th time you hear it, even though you know exactly what is coming. The prediction system re-engages every time. The anticipation is rebuilt. The resolution or subversion lands again with the same force because the emotional system does not habituate to it the way it habituates to most stimuli. But this still does not explain why the reward takes the form of a physical shiver rather than simply a feeling of pleasure. Why does the brain's response to a particularly powerful musical moment produce a cascade that raises the hair on your arms? The leading hypothesis connects Frisson to the body's evolved response to vocal communication. Human beings are exquisitely sensitive to the sound of the human voice, and specifically to the acoustic features of the voice that signal extreme emotional states. A voice breaking with grief, a voice raising with sudden fear, a voice trembling with overwhelming joy. These vocal qualities are not just emotionally legible, they are physically compelling in a way that bypasses conscious processing and produces an immediate physiological response. The hair standing up, the skin responding, the autonomic nervous system activating. Music, in this framework, is exploiting a system that evolved for something else entirely. The acoustic features that produce frisson in music, sudden shifts in volume, the entrance of a new voice or instrument, a chord that introduces unexpected harmonic tension, a melody that reaches the top of its register with what sounds like strain or longing. These are acoustic features that share properties with the human voice in a state of extreme emotion. The brain hears them and responds the way it was built to respond to a human being overwhelmed by feeling. Not because it is deceived into thinking a person is crying, but because the same neural pathway is being activated, and it produces the same physical response. This is why certain types of music produce frisson more reliably than others. Unexpected entrances of new instruments, sudden dynamic shifts from quiet to loud. Appoggiaturas, the musical device of reaching toward a note that is not the expected resolution before falling to the note that is, produce frisson with remarkable consistency, because they mimic the sound of a voice reaching past its comfortable range, straining towards something it can't quite hold. The appoggiaturas in adults someone like you were analyzed in a 2012 study specifically to understand why they produce such powerful emotional responses in listeners. They were not doing it randomly. They were doing it through a specific acoustic structure that the human brain is built to respond to. The 30 to 35% of people who do not experience frisson are not less musical and are not less emotionally sensitive in general. They simply appear to have a less permeable boundary between the cognitive system that processes music and the autonomic system that produces the physical response. The processing happens, the musical expectations are built and violated and fulfilled, but the cascade that crosses from the auditory cortex into the autonomic nervous system does not fire with the same intensity or consistency. What makes frisson genuinely strange from an evolutionary perspective is the question of what it is for. If it is a side effect of the vocal sensitivity system being triggered by music, then it has no direct adaptive purpose. It is, in a sense, an accident, a misfiring of a system that was built for something else entirely, producing an experience of profound beauty that the system was not designed to produce. But this framing may be too narrow, because the experience of frisson is not just pleasant. Researchers studying it consistently find that it is described as one of the most meaningful aesthetic experiences people have. Not just pleasurable in the way that eating something good is pleasurable. Meaningful, significant, connected to something larger than the immediate moment. Connected to other people, to memory, to loss, to joy, to the sense that there is something important that cannot be put into words, and that the music is the closest thing to putting it into words that language itself cannot manage. This capacity, to be moved by something that has no survival value, to experience profound meaning in organized sound, to feel connected to something beyond yourself through the activation of a biological system that was originally built to detect distress in the human voice, may be one of the most distinctively human things about us. Every other animal hears sound. We are the only one that hears music, and the shiver that runs across your skin when a piece of music does something unexpected and perfect is the sound of your nervous system recognizing something it was never designed to recognize and responding to it with everything it has.